Hello and welcome to this exciting video where we'll be discussing one of Optilogic's newest and most advanced engines, Intelligent Greenfield. I'm thrilled to have Optilogic's Senior Director of Product Management, Jim Wilson, joining us today to give us an overview of this incredible tool. Greenfield is an innovative engine that has been designed to help customers find the optimal facilities from a vast number of automatically generated candidates. This tool is ideal for those who are considering high-level greenfield networks and need to narrow down their selection for more detailed analysis in NEO, also known as our Network Optimization Engine. In this video, Jim will be walking us through the key features of Intelligent Greenfield and showcasing how it can transform your supply chain strategy. From its powerful algorithms to its easy-to-use interface, you'll get a comprehensive look at everything this tool has to offer. We hope you enjoy.
So let's take a look at why it's Intelligent Greenfield. Well, firstly, we can consider many candidates or potential locations for a new facility, and these are all auto-generated. We're also able to augment those with our own candidate locations. We can also optimize on cost, considering the trade-off between fixed facility costs and the transportation cost to fulfill the demand. We can also consider service levels, and we can consider those across multiple bands. So for example, we could define that 80% of our demand must be serviced within 300 miles of a facility. The next 10% must be within 500 miles, etc. We can, of course, consider existing facilities and existing infrastructure within the network, and also capacities for both existing infrastructure and for each of our candidates. And we can also define the number of facilities specifically that we want returned. And this allows us to understand the optimum, but then also understand specific number of facilities around that optimum. So let's take a look at how this could be applied. So firstly, we're going to get the cost optimized number of facilities that meets a defined service level. And let's say in this example, that's 10 DCs. That's our optimum. But we can also then go on to define the number of optimal locations. So we can explore what happens if we move to 9, and we can see the impact to both cost and also to the service levels that can be achieved. And then we can look at 8, and we can see as we get down to 8 that our service starts to drop off and our costs start to increase. So being able to understand the optimum, but also explore solutions around that optimum is extremely powerful. So now let's jump into the template model and see the data that we've got. So to make Intelligent Greenfield run, we really just need customers and demand associated with those customers. So we can see here that we've got about 1,300 customers imported to the model, and these are in North America. We jump across to the map, we can just see what that spread of customers look like. And then the other table that I've imported is customer demand. And we can see here that this is demand for all of those customers. I've actually got product groups, different product groups and periods in here. When we run Intelligent Greenfield, we'll aggregate across those and we'll work with an aggregated demand. And I've also opted to create different service level bands. So I've defined 3 bands, and here I'm able to define the percentage of demand that must be serviced within each of those distance bands. So 50% within 300 miles, 70% within 500 miles, and then the remaining 30% within 750 miles. And finally, in terms of input data, I've also created a record for Atlanta. So this is an existing facility that's within my network, and I want to consider it as part of the Intelligent Greenfield analysis. Now let's take a look at the scenarios that we want to explore. So I firstly want to understand what the optimum looks like, but considering Atlanta because that distribution center already exists. I then want to understand what the cost optimized network looks like without Atlanta if we go true Greenfield. And then I've also got another scenario that looks at increasing demand. Now we'll see when we get to the results, this returns 8 new facilities. So I've also created scenarios that allow me to go to the left of that and explore a solution if I reduce the number of facilities from the optimum. So let's take a quick look at how we've created these scenarios. So these runtime options are available as we run scenarios, but obviously we want to be at a hyperscale. So I'm defining these in items. We can see here that we have a parameter that allows us to exclude all existing facilities. In this scenario, I want to consider Atlanta, so I've set that to false. Atlanta is going to be considered as part of the Greenfield analysis. I want 7 optimal facilities, including Atlanta, so I've set the maximum number of new facilities to 6. And then I've also set the cost per unit distance. So this represents the transportation and also a fixed cost for each of the candidate facilities within the solution. Where we're looking at a cost optimized scenario that's excluding Atlanta, and then I'm setting this to true, so we're excluding all existing facilities. I have nothing defined for the number of new facilities. It's going to return the optimum, and then of course I've included the fixed and the variable costs. So we can now go and select all of those scenarios. We'll select the triad intelligent greenfield engine and an appropriate size of resource depending on what we need. And then we can hyperscale all those scenarios, running them in parallel. So once we've run the scenarios, we can go to analytics and we can start leveraging template dashboards that are available to us for Greenfield. So let's look at comparing scenarios. If we start with the cost optimized with Atlanta as a fixed facility, then we can compare that very easily to the true Greenfield, the cost optimized without Atlanta. And we can see that the fixed costs are the same, and that's because there's the same number of distribution centers. There's 8 DCs in the true optimum and then 7 DCs plus Atlanta. And the flow cost of about 28 million goes down to just over 24, so goes down by about $3.5 million. And that's really the cost between the true Greenfield optimum and considering Atlanta, which is already an existing facility in our network. We've then got the comparison between the true Greenfield optimum and where we increased demand by 10%. And we can see that the transportation cost increased by about 2.5 million if we take the Greenfield and then we increase demand. And then we can take the optimum with Atlanta and compare that to if we move to 7 facilities. So this is where we're exploring sort of to the left of the optimum. And we can see that though the fixed facility cost goes down by 4.5 million because we've taken a facility out the network, our transportation cost actually increases by over 6 million. And then of course we have the comparison between our true Greenfield and what 7 optimal facilities without Atlanta would be. And again we see the same increase in transportation cost, offsetting the benefit by reducing that DC. So we also have a template dashboard that looks at service level. And here we're looking at the service level for the optimum, where we're considering Atlanta as a fixed facility. And we can see that in the input, the service bands, we defined a hard constraint to say that at least 50% has to be serviced within 300 miles, 70% within 500, and the remaining 30% within 750 miles. And we can see that with the optimum network that we've identified, we're beating that quite significantly. So about 87% of our demand is serviced within 300 miles, and then we're 95% within 500. So we can compare that, of course, between scenarios. So if we go to our true Greenfield, where we're not considering Atlanta, then we actually get about 2% additional demand service within that 300-mile band. So we can conclude from this that Atlanta's not really hurting our service levels in terms of being a fixed DC and not being a true Greenfield optimum. So we also have template maps that show us really powerful visualizations of the selected facilities. So here we're looking at the optimum, including Atlanta. So we can see that Atlanta is a facility that's part of this solution. And then we have the 7 additional facilities that the Greenfield has found for us. But we can also see that we've got layers for each of our service bands. So we can very quickly visualize the green, where we're fulfilling customers within 300 miles, and then the orange for 500 and the red for 750. We can also visualize the differences between scenarios. So here on the left-hand side, we're looking at our optimum with Atlanta that we've just reviewed, but we can now compare that to the true Greenfield optimum. So we can see now that Atlanta is no longer part of this solution, and actually it's moving that Atlanta DC much closer to a very large amount of demand that we've got up here on the eastern seaboard. And this is what's driving that reduction in fulfillment costs and transportation costs to fulfill the demand, but also driving up that 2% in terms of the increased service levels within the 300-mile band. And then finally, let's just go and change from the cost optimized to the 7 optimal facilities. And again, we can just visualize that if we were to go for 7, how that would change the network. And effectively what we're doing is we're seeing a degradation in service to this area of the US by losing that distribution center. So this model is available within our resource library, so please go and log on and check it out.